Well, good evening, everybody. We're Team Deep Data. I'm Kimberly, and these are my teammates, Jack, Michael, and Peace. To kick things off, we'd like to give you a little bit of background info about the problem we were given to tackle. And that is our sponsor's aim is to create, machine learning algorithms that will be implemented into various autonomous devices from KGCOE. Before any implementation can take place, however, they must be tested in a laboratory setting first. And in order for any testing to take place, they'd need access to a large amount of experimental data that they'll be able to easily view. And that's where we come in. The idea behind EDCS is a web app that's able to easily connect with any device from KGCOE, such as their RC car, and that the user will be able to manage and view any of the data on the web app. And then this data can include anything that the user deems useful, really, such as the device's position, its temperature, and its pressure. And an authorized user will be able to securely log into EDCS and be able to view the data in real time. This data will, of course, be grouped into its associated experiments. In addition to this, the user will also be able to download the data from the website, the web app, into CSV format so that they can use it for whatever they need to. They'll be able to add custom user inputs. That includes existing data that currently exists on the web app and adding new data to it. And also they'll be able to view the data in the forms of graphs. And now I'll hand it over to Jack, who will tell you a little bit of our system architecture.
In order to build this system, EDCS, we had to first design an architecture that would be feasible to allow us to complete these requirements and features. And so what we came up with was this system that's split into three main components: the front end, the back end, and the device. We're going to start off talking about the front end part of the architecture. The front end is the website, where an authorized user can log in and view data, create experiments, register and link devices, etc., much more. And so for this web app, we wanted to create a nice modern and intuitive application that anyone could pick up and use relatively easily. For this, we decided to go with Google Material Design, which you see in places such as Gmail and Google Drive. And it's very easy to use and provides the user with a great user experience. And so why do we choose Angular for this application? Angular is also owned by Google, so that means that Angular is always up to date on the latest material design specs. Also, EDCS was to be a small to mid-size web app, and that it was also going to be a single-page application, and so Angular worked very well. To host Angular, we used an Nginx web server because when Angular is built, it is essentially a series of static web pages, and that is where Nginx excels over Apache. Moving on, we're going to be talking about the backend part of our architecture. The backend consists of two main parts: the database, where the data from devices is stored, and the API, which is an application programming interface. The API provides an abstraction of the database because we knew that we were going to have multiple clients that needed to read and write to our database. And now if there's any changes to the database, we can use the API to cover those changes and kind of abstract over them so that the clients are not negatively impacted by any changes in the database. So for our API, we decided to go with Node.js because it's very reliable, and the support for Node.js makes it extremely maintainable, especially going forward in the future. And for our database, we went with PostgreSQL because it's a reliable and flexible open source SQL database. And we went with SQL because we're able to create relationships between all of our different data types. This includes experiments, output types, device outputs, devices, and more. And the third and final part of our system is the device part of the architecture. And this is basically just a Python script that takes the data from devices and sends it directly to our API. And we used Python because Python is fast and it's portable, and we wanted to be able to send data from anywhere, from any device. And so Python was a really great choice for EDCS. Next, I'm going to hand this over to Peace to talk to you about the backend features.
So I'm going to highlight a little bit of what our backend features are like. So our data is served over HTTPS, and this provides our users with security. Authorization is done by using JSON Web Tokens And so this is assigned to users upon login. There's complete authorization and authentication built into the features of the backend. So what I mean is when a user who is not logged in or not authorized attempts to perform an action that should otherwise be done by an authenticated or authorized user, they will be bounced back. And our front end supports this, but our back end actually enforces it. Another thing is all of our data entries have the ability to be created, read, updated, and deleted. Our deletion is soft, and so that means that in our database it still exists, but the deleted at column will be updated. All of our data has timestamps associated with them, and so this helps us with easy history tracking. And Mike will talk to you about the hardware features.
So we wanted to have a device that was capable of interacting with our API, serve as an example for future devices to follow. For this, we decided to use an RC car from the Department of Mechanical Engineering because it was a simple device that was easy to modify, a good first step. We added an SD card shield to the device's Arduino so that it would be capable of storing a significant amount of information. And we created a Python script and a corresponding .exe version so that wherever you put that data, if it's on a device that's connected to the internet, you could easily send it to our API. Give it back to Peace to talk about front-end features.
So some of the features of our website include the ability of our users to register and log in. They can also request for an access level with reason. They also have the ability to create experiments and manipulate the data within these experiments. They may also link devices to their experiments and add user inputs, which could be something like the removal of a battery. They may also actually input simulated data where, like, if you can't connect your device to the website, you can just input it manually. Users can also view and download all of their experiment data, and they can manage their account details depending on whether you're an admin or a regular user. So Jack is going to demo for us.
For this demo, what we're going to do is we're going to go through several of the core features that a member of our sponsor's lab may be using EDCS for. And the first step for that is to register into our system. Now when you register in the system, you're provided with a default access level. And what you have to do if you want to have the ability to write data to our system is you have to request a higher access, and an admin in the system has to approve that. So if we look here, we're brought to the registration page where you fill out your name, your email, and your password, and then you have the option to request higher access level. So for this user, we're going to request an elevated user access, and then you can put in the reason for requesting that access. Now if we go over to an admin user, we can see that they have a notification from Jack Smith and that they want to have elevated user access. Now if the admin grants the access, when Jack Smith goes back and logs into the website, he's going to have that elevated user access and be able to do things like write data to the system and do things such as create new experiments, which we're going to talk about next. Creating a new experiment using EDCS is very easy and straightforward, and there's just a couple things that you need to do. The first thing you need to put in is the name of the experiment, and the next thing is the start time. And that's all you need to get started creating experiments in EDCS. You also have the option to add some notes to the experiment and also link devices to the experiment right here directly. But to link devices, the first thing you need to do is register your device. To register a device, it's somewhat similar to registering a user, where an admin also has to go on and approve the device so that you can't get unwanted devices sending data to your system. So as an elevated user, such as Jack Smith, he can go in and click on Add New Device, provide a name for the device, and a unique identifier for this device. So if we say this is a new RC car, then we give it some ID, and we also give it a secret. And a secret is somewhat similar to a password that a user would use when they're logging into the system. Now we've created this device, but it hasn't yet been approved by the admin. So for this demo, we're going to use a device that has already been approved. So we go to our experiment for demo, and here we can link the original RC car, which has been approved into our system. And as you can see, the device has been linked to our new experiment. Now that this device has been linked to our experiment, the device can send data. So as you can see here, there's a little bit of data in the system already, And we're recording the wheel speed of the car in degrees per second. And we want to see how adding a weight on top of the device affects the speed of the wheels. In order to do that, you click on this plus button here, and you get to go to the screen called Create User Input. You select the device, the original RC car, and we're going to say we added a 500 gram weight to the RC car at this time. And then you can save the user input and you're all set. So how does this help? After this user input's put in, the device collects some more information about the wheel speed, and as you can see here, the wheel speed has decreased a little bit. Before the 500 gram weight was added, the wheel speed was around 80 degrees per second, and after the weight's added, you can see it drops down to about 50, and this data is all really easy to view right inside the app. And also you can download this data directly into a JSON file that you can store on your computer and do whatever you want with. And that concludes the demo for EDCS for today, and I'm going to hand it off to Peace to talk about what requirements were met.
So what requirements are met, which ones couldn't we meet, and why? So this is a list of all our desired features that we saw earlier, and we've highlighted the ones that we couldn't meet. They are view graphs of data and the real-time updates from devices. So these requirements will be the future requirements for EDCS. But why weren't we able to accomplish these? So for view graphs of data, this was originally low priority and it remained so throughout the entirety of the project. In addition to that, there was miscommunication about the software that was available on these devices that we were working with. Our project proposal mentioned that there were APIs that could be worked with. However, we realized later that this was not the case. We then redirected our resources into developing software for devices. And so we had to push off data visualization. This is also a factor for real-time device updates. We were unable to get access to our devices early, and the fact that the APIs were not present as we thought they were. The devices also did not have software or hardware that supported real-time updates, and so we ended up having to renegotiate with our sponsor and push these two features further out. So what were some of our challenges? And Mike will talk to us about that.
One somewhat unique challenge we encountered was that our SE provided virtual machine was compromised. It was on May 2nd, the sysadmin took it down, and that was when we began the slow process of getting it set back up. It was delayed even further when summer came and the sysadmin went on vacation. As a result of this, we just didn't have our production VM for the latter half of the project. We dealt with this by using our local environments for demoing. A more common challenge you might find is communication issues. Inevitably things would come up, people would miss meetings, and in these cases occasionally we couldn't reschedule the meeting. Things wouldn't work out. Sometimes we attempted to use email in this case, which just can't compare to face-to-face communication. It can take days to get a response. You can't convey the same amount of information. And on top of this, it wasn't just our first project for us, but also our sponsor. So there was a learning curve on both ends about giving good information and getting good feedback. We dealt with this by using some of the tools that are available to us, such as calls or screen sharing, so that when we couldn't meet face-to-face, we could at least do better than email. And also following the tenets of Scrum helped, encouraging regular meetings, regular demos, helped us to convey information as best as we could despite the downsides. Another problem we encountered was delays on our hardware side of development. We tried to start our first hardware story in Sprint 2 and finished it around Sprint 7. Again, this was partially due to communication issues where emails would take a long time to get a response, but it was also that we had lots of uncertainty. We weren't sure what parts we needed to order, we weren't sure what devices we had available or what device we wanted to use, and even after everything was decided, it was still some lag time before we got physical access to the device and its code. We dealt with this partially by shifting our focus and developing on the website and the API, as we could do that and continue doing productive work despite the hardware being blocked. And we also made a thing during our weekly meetings. We talk about our needs for that week so that something like hardware needs wouldn't get forgotten and pushed to the side till the end of the project. Overall, things that went well. We reacted as best we could to losing our VM. We didn't lose too much doing demos on local machines without a production VM. We did good to choose Scrum for project with a first-time sponsor. It helped us communicate better, and the frequent demos helped us get better feedback. We also did well to be able to shift focus between stories when the hardware stories got blocked. If we had a hardware guy that could only do hardware, he would have been very unhappy for sprints 2 through 6. Things we could have done better. We should have proactively done something about missed meetings. This is a risk we could have anticipated and had a backup plan, backup tools, instead of reacting like, oh, the meeting is missed, what are we going to do about it? We also should have mitigated our hardware risk better. We could have done research earlier to figure out what parts we needed and what device we wanted. If we had gotten our hardware stories done earlier, mitigated that risk, we could have had better demos, maybe even a beta version for the mechanical engineering department to play with and get better feedback on. Lastly, Kimberly will talk about moving forward.
Thank you. Extensibility was one of the core elements that we took into consideration when discussing what our plan moving forward was going to be. We factored it into our design. It was a core element of our design, especially considering that our backend was made specifically for it to be easy to add new features onto it, such as the ones we discussed earlier, like being able to view the data graphically, and also being able to update the information provided by the devices in real time. Additionally, we had to tackle the one elephant in the room that came about because of our production VM, and it was, how are we going to continue hosting EDCS when our production VM gets taken down inevitably when we graduate? And after carefully considering our options and researching as much as we could, we proposed that KGCOE itself would host EDCS on their servers. And this would also give our sponsor and the college total access and total control over EDCS and its production environment. This also provides ample opportunity for beta testing as well as user feedback, in that whenever the new future requirements are added to the production environment, it'll be able to be implemented immediately and tested, so forth. And that concludes our presentation for today, and I want to open up the floor to any questions you may have.
So you weren't able to achieve real-time data. What data rate did you design for?
We designed to allow real-time data to come in, although...
What do you mean by real-time?
Real-time as in the device is constantly sending the data to the system.
But how much, what rate?
At virtually any rate, the resources of the system could be scaled up, although we didn't, because real-time data wasn't a priority, we didn't have a focus on synchronization and the working with concurrent threads and things like that, because with what we ended up going with in terms of priorities, it was more of a small scaled version where all at once device data would be updated, and so that could be done with a small amount of resources, and with the script that uploads the data, it's kind of uploaded in a batch as fast as the program can run through. So our API supports very high speed of saving the data. So in terms of being able to support real-time data, the speed at which the data can be sent through with our API running in Node.js is a very high level. But without devices that were hooked up directly to the internet, we were not able to test with and develop upon a real-time system. Does that answer your question, sort of?
Sort of. Whenever somebody says real time, I say nothing is real.
Yeah. So originally, our plan with how the system was going to be was that we wanted to have our backend API be running constantly, so that if there were a device that were hooked directly up to the system, it would feed its data directly through its code, its Arduino code, directly into the API whenever it, through whatever clock cycle it used, directly into the API, and then from there it would get stored with a minimal amount of latency.
Okay, thank you.
Any other questions?
Question, anything?
Let's thank the team.
Hi everyone, we're Team TBA team name. I'm John.
Ben?
Roger.
I'm Corkit.
So I have an agenda outlined on the side there. Pretty much we're going to be going over a project overview that's going to include our background of the project, what we were working towards. Then I'm going to go over some accomplishments. That's going to include a current status of where we're at now. We're going to go over a solution overview, sort of what we implemented and why.
Oh, I got
Plug it up. No, plug it
Okay, then we're going to do a quick demo of our completed project up to date. We're going to go over some results of our scraping data. And then we're just going to go over a reflection, what went well, what didn't go so well during the project, and then any future plans that we have for our sponsor, our suggestions for them.
So the project overview has changed a little bit from when we did our intern presentation. Constellation brand still wants that data from those independent and smaller bars and restaurants to see what they're selling and see how they can target and find trends in what people are drinking, where, and stuff like that. However, there has definitely been a switch in focus from less depth-focused scraping, trying to get as much information from a few sites as possible, to a more general scraping, a more breadth focus, where we have maybe one or two methods of scraping that can apply to a lot of different websites. So yeah, that also sort of snowballs into the changes in the sort of the amount of data we're collecting, where it's a lot easier just to focus on drink names instead of prices, specials, and stuff like that, just so that we have a spider that will work for a large amount of websites and pull some data.
Alright, so for our current status right now, and the accomplishments that we've achieved so far to this point, pretty much at this point in the project, we are able to feed a set of menu URLs to the scraper. It can take those menu URLs that we feed it, and it can retrieve drink data for those menu URLs. We are able to implement a bunch of strategies. Obviously, all websites for restaurants and bars are not going to display their drink data all the same, so we need to implement these strategies to try to hit as many sites as we could, since we know that 100% of websites is not possible. So some of the ones that we use the beer menus and Untapped APIs. So some websites use these APIs to display their data on them. For these websites, it's fairly easy. Each website displays the data in the same way, so we're able to consistently pull the data for those websites every time. And then websites that have PDFs, pretty much we're just looking for PDFs on the page. We pull those no matter what the PDF is, and those are examined by someone later to determine if that is a menu containing beverage items. And the last strategy we have is pretty much the strategy if all else fails. If we don't determine it uses this API, if it doesn't have PDFs, doesn't have this, then we go to a general scraping strategy. This strategy pretty much is an HTML parser. So we take the HTML, we parse it, look for beverage items, and if we find any, that's what we store then. And so with those drink details, we have a MySQL database. We store the drink details there. We store our scrapes there, and then we're able to store our PDF menus as well.
Okay, so next I'm going to go over how we implemented our solution. So a scrape job, it starts, you input a website URL, then we will scrape through that website and traverse it until we find a menu. And then we will take that menu info, which is either HTML or PDF, and then scrape through that to get drink data. And then we'll store that in the database. Another thing is if we find a link to a menu, we store it in the database for further reference. And also, we save all the HTML in the database. So this is a chart that goes over the specifics of a scrape job. So you input the URL, and it goes to the menu finder. And the three results are it finds nothing, it finds a menu in the HTML, or it finds a PDF, and it'll store all of that in the database, records of it. So next what happens is the menu gets pulled from the database, and we run the strategies on them, and you can see those diamonds in the bottom right corner. So we'll sequentially run each strategy, and all the data that is produced from those strategies gets put in the database as drinks. So this is our ERD, like what we're storing in the database. I'll go from right to left. So you can see a location up there that represents a physical location for a bar or restaurant. And then there's a menu, which is the menu for that location. And then you can see menu drinks there. That's the new data we're getting from each scrape will be stored in that. So a new menu drinks will be created for each scrape. And we also have drinks for each menu drink. Here we have many drinks for many drinks. That's it. So this is our old ERD. There's a couple important things to look at. We denormalized it for simplicity's sake. So you can see for the drink, we have serve method, drink type, and serve size. Those were all condensed. Another thing is we didn't have time to implement some things, such as drink specials, which are specials, and detecting chain restaurants. And another thing, we added blobs of menu HTML and PDFs to our new ERD.
So I'm going to do a bit of a demo, since it's mostly data thing, can't really do a traditional demo. But here's the starting point of all the scraping, the base URLs for restaurants and bars, stored in the locations table, and then I'm going to sort of use a web page to sort of go through exactly what's happening when general scraping is done. This website doesn't use the APIs, so it uses general scraping method. But before we scrape any drinks, we have to find the menu. So we look at the home page here, and we try to find any links that could be a menu. So first, we find the word menu. That could be a drink menu. Then we look at it, and it's a food menu. So there's nothing on that page we want. So we're back at the home page. And then here we see on tap. Now that could be a drink menu. So then the scraper will look at it and see that since there's a bunch of beers here, that this is in fact a beer menu. So once beer menus are found, they are stored in the database as such. I've condensed out a lot of the columns, including on the first database screen capture I showed you. I'm just showing some more important stuff. In this case, page title, the URL, and scrape date. So back to the menu. Now we're trying to find drinks. So we look at one of the drinks in the text here, and granted, before this we would have tried all the text on the page, but that wouldn't have passed this test. The test being that we take some of this text and we try to compare it to our known list of drinks that we have in the database. And we see that Blue Moon Belgian White matches up well with Blue Moon Belgian White Ale. This match is so strong, in fact, that we now are going to do some HTML traversal. So when looking at the page itself, we see that it's in that div at that level with that class name. At that point, we can now say that since we see another div with that class name, we can also assume that everything else there is a beer as well. Now, granted, if you've ever done web development before, you'll know that this could be a flawed assumption to make, and I will admit that it can be. Class name is probably our weakest assumption and one that, at least theoretically, could cause the most trouble compared to our other sort of traversal method, which would be going off of ID, and it can also handle, let's say this had an ID of 1, 2, 3, each one had an individual ID and it sort of incremented. We've also had it working so that it goes through each one. But it's seen this other div and it assumes that those are all drinks as well and save those to the database in a table, which the most important column to know about is the name. And this is not the drinks from, these are not the drinks from that list, but same sort of principle applies to what you kind of see here.
So we had a testing set of 129 URLs to use to gauge how well the web scraper is doing. So I'm going to walk you through sort of the menu finder portion of it and the menu scraper portion. So when it's finding the menu, you're inputting the 129 URLs, and you get 138 URLs out of it, which are listing all potential menus basically. So of those, 47 of them have the link text match something that could be a menu. So on tap, beverage list, drink list, menu, something like that. In addition to those, when looking at the page text of those menus, 48 URLs also have words in them that can be something that's the beer menu, like Pilsner, Stout, Ale, stuff like that. And 44 URLs, they don't have it. They could be either not online, or they just don't have a drink list, or some different layouts that have links as images don't get picked up by the menu finder. A lot of the page matching. So when we move on to menu scraper, we have this pie chart over here where the big chunk is the URLs that have drinks returned from the scraping. So while the big chunk, there are false positives, such as some words that get high text matching, such as breakfast and white, stuff like that. Those get picked up as well, unfortunately. We have 7 URLs that are consuming API, like beer menus and Untap, and those are the targeted scrapings that we can do and pull stuff like price as well. We have about 20% of the URLs found have PDFs in them, which get picked up, merged, and then put into the database. And about the rest of it is there's no text matching at all. So when you compare the drinks scraped with the drinks available with an answer set, you get about a 67%, not including the ones that don't have a menu but still return drinks. And the thing about the text matching is also we are working from a list of a list of beers, all beer products that are available, and of course, if there's a microbrewery that has that isn't on that list, that won't get picked up as well.
Right, so next we're just going to go over what went well throughout the course of the project. So the first thing that we thought as a team that we did well was to respond to change. So we had one major requirements change during the course of the project. So this was at the beginning of the second semester. We had talked about it earlier in the presentation where we had to refocus and switch from a depth-first approach to a breadth-first approach. So pretty much at the beginning we were working on, let's say, the website that Roger just showed in the demo. We were working on trying to get as much data as we could from one website at a time. So I believe it was JD Oxford's. So we would get a strategy for that website, but it would be so fine-tuned that it wouldn't really work with another website. So the way we were doing it, we would try to get the drink name, the ABV, which is the percentage of alcohol in the drink, the serve method, such as bottled or on draft, and any other information on the page. So with that, we simplified that to just a drink name, and we were able to implement a breadth-first approach, and then with the general scraping method that we've gone over, we've been able to expand to a way wider horizon of websites and retrieve data from all of those. Another positive thing that went on was that we had regular meetings with a sponsor. So we were lucky we had 2 sponsors to meet with. So if one of our sponsors did have a conflict, we were usually able to have a meeting with just one of them at a time. We did, as a team, have some things pop up as well where certain team members can show up to meetings. However, a majority of our team was usually present at all meetings. And then team familiarity with the technologies used. So to implement the web scraper, we used Python. And I'm sure all of us here in the room have used Python at some point. We used it in CS1, so it was a pretty easy transition in the project. We didn't spend a lot of time researching during the project, so we were able to jump right into the code fairly fast. And then the last point I made was just continuous project of the continuous progress of the project. So especially during the second semester, once we switched our approach to a breadth-first approach, we were able to implement these strategies pretty consistently on a sprint-to-sprint basis. So one sprint we were able to produce the beer menus API strategy, we were able to produce the untapped API strategy the next week, PDF strategy, and then at the same time we were able to have other team members focus on the general scraping strategy and refine that to what it is now.
So I'm going to talk about what didn't go so well. What we... Not that many. So the first point, and really kind of the central point for us in the semester, not only in its importance, but actually in the time it got to happen. It happened kind of near the middle of the semester. We had that big change of plans, moving from the depth to the breadth of our focus. What that sort of caused is near that time we had been working obviously on work to make that happen, but also other priorities that once we changed plans kind of got left by the wayside and we weren't able to pick them back up again because of the reprioritization. And in addition, there was some crunch at the end of the semester which made it really getting to those things pretty much impossible. The team meetings, not meetings with sponsors, as we were talking about in the previous slide, there was a point, it wasn't throughout the semester, but there was a point where there was a couple times in a row that we weren't able to meet, which did interrupt our progress a bit. And the last point I wanted to make was some technical issues that we experienced, one of which that was a big one was issues with websites that use JavaScript. We had to use Selenium initially, but that made it extremely slow. So we actually found something called Splash, which allowed us to render JavaScript, but much more quickly.
So with a project like this, there are so many restaurants, bars, and stuff like locations like that in the US that the scope is pretty large. So obviously, more strategies that would fine-tune the, make it so that there are less false positives and be able to scrape more data is always needed. One thing that we encountered that there were a lot of menus, about 15, that had images as their menus as images and instead of PDFs, which made it difficult to actually to end up detecting while we're doing the scraping job. So something along the lines of, in addition to the PDFs that were scraped as well, some OCR PDF reader to be able to parse that text that is in the PDF is also very good. As I mentioned it before, there were 3 or 4 websites in that set that had links that that weren't text. They were pictures, which means that we would also need some sort of OCR to actually be able to parse that, as the menu finder wouldn't be able to pick it up. So, and again, more detailed scraping. Most of the time, the way our architecture is set up right now, that we are only detecting if we go to a website, if it's consuming an untapped or beer menus API. Instead, maybe going to the site itself and trying to getting access to that API would be able to return more data. Same thing with specials and prices. It's sort of things that were mentioned in the initial project plan that we couldn't get to, especially considering that being able to match specials and prices to beer names and stuff like that when it's not in a table is fairly difficult. Also, data visualization was also something that was mentioned in the project plan, which we just couldn't get to because there was a lot of there was a lot of other stuff going on at the time. Questions?
What kind of strategy or algorithm or whatever did you use to do the matching of text?
I'm referring to the links or the beers?
The beers.
The beers. So there was there's a sort of matching, a text matching library. It's the right thing is it's a library that sort of matches it and it gives you a match ratio. When we're doing sort of the strong match to say, like, can we actually do traversal, we have a rate, we look for a ratio about 0.92-ish is where we have it. And then if we're looking at something to match it with something in the database, it's like 0.75-ish. I don't know the exact the exact way that this number is calculated. I know that this is an interesting problem. When I was sort of looking into it in my research, so I don't have that very detailed information, but kind of just use the library for the short answer.
I'll ask the other one then. I'm sorry, go ahead.
What do you do with your PDFs after you store them?
They are stored in the database, and I did not do that actually. So.
Yeah, so if there are multiple PDFs in the on the site, it'll detect that, it'll merge together and put in the large blob that is in the database. So the goal was to, even though we couldn't get the sort of detail and the granular detail that Constellation Brands needed, but we wanted to give them an avenue to be able to get more data with our existing code. So having storing those PDFs would open an avenue for Constellation Brands to come out later with like an OCR reader or something like that to be able to pull data from those PDFs. It was the same thing with why we saved the page HTML as well. If it's realized that that not a lot of beers were caught, but then there were a lot of beers available, Constellation Brands would be able to go into there and see what's going on and maybe develop a different strategy and or way of putting that data.
Got a question. So I noticed you, the example you gave, you looked at a menu, it was a food menu, then you found the on-tap menu. What kind of process did you go through to try to figure out what keywords to be looking for? You know, you could be looking for drinks, you could be looking for on-tap, you could be looking for maybe other similar terms.
Right, so we kind of have a sort of set of keywords. We sort of, in our development process, started with, okay, stuff that we automatically think off the top of our heads could be menus, put that stuff down. And we kind of had we worked off a small set of websites initially. So when we go there and we run the scraper against all of those and see how many menus we found. And all these websites had menus that were accessed through links. So if we didn't find all of them, we go back to that and say, okay, why didn't we find these? What words do we need to include? And the reason we go to stuff like menu now is because, yeah, the menu probably is going to be a food menu, but there's some that just put everything all in the same menu. So you kind of have to keep it a bit loose standard to allow you to check the page when you get there. We don't just sort of take the page, anything that could be a menu, and then try to scrape it. We sort of look at it to see if it is a drink menu first.
Did you ever consider using machine learning to help with scraping?
Yeah, okay, so we verbally considered it. But seriously, and I think we might have done some light research on it, but in terms of implementing something like that, I think we favored something that we knew we could have a solution in the end for, instead of walking up in front of you guys today and saying, you know what, we tried machine learning and we have absolutely nothing because we didn't manage to get it to work. So that's kind of why we didn't do it.
Yeah, at the end.
Thanks.
Hello, my name is Kirk Wallach.
I'm James Tarica.
Brian Pachano. And I'm Eric Donch, and we are Team Vegetation Conservation, and we are creating My Conservation Life, led by the one and only Tom Snyder. Glad you made it. So, our team has laid down the groundwork for a conservation management tool for the Seneca Park Zoo Society, as well as other conservation organizations to collaborate, record, and track everything within their conservation projects. We wanted to make it easier for donors, scientists, and even the general public to take a peek into conservation projects, as well as to view the project progress, impacts, and view the details of their own donations and what the result of their donations may be. Last semester, during our conception phase, a few things we planned on having was the ability for conservation staff to organize conservation projects, create a portal for field workers to enter and review new assets for a project, as well as a portal for donors to see all the assets that they donated for. And we are happy to announce that our goals have been reached. And I'll pass it over to Brian to give a little bit more about the requirements that drove our goals.
Yeah, so to achieve those goals, when we as a team, we first came together, we really needed to understand the domain of conservation as a whole. As when we came in, we had no idea what was going on with that. And to not only apply that knowledge to creating a product for the zoo administration to create and manage their conservation projects, but also to make it a collaborative experience between the public and their local zoos. So the first major point that we hit is that we needed to support many different user roles. These are very unique roles within the system. They need to have their own processes in order to carry out their jobs. We also need to be able to handle large volumes of data. This is both geospatial and spatial data, and then it is also structured and unstructured, so asset data from a project would be a structured piece of data, like a tree, to moisture readings from a sensor would be unstructured data. Then we need to be able to tie that to physical locations across the globe and how that relates over time. And lastly, we needed to aggregate all the data across every project and be able to come up with meaningful impacts that these projects have had. So far, My Conservation Life has 3 main apps, each correspond to a unique work role. We've got the zoo staff, they're the ones who create and manage conservation projects. We've got the field participants, they're the ones on the ground who collect, report, and insert data into My Conservation Life, specific projects of it. And then we have the public community, who are your everyday zoo visitors and people around the area who are just interested in what the zoo is doing. They're able to peer into the projects that the zoos are having and are also able to donate to sponsor specific assets from projects. And through there, they're able to track how their asset has impacted the project as a whole and see the progress that they've had over their lifetime. So, a little bit about the architecture and design. We are primarily built upon Salesforce. Salesforce, it's a customer relationship manager and has solutions for a lot of things like customer service, analytics, and marketing. But most importantly, it is highly configurable and allows for custom development on top of it using their Lightning Web Component framework. We also leverage the use of Salesforce apps to bundle each role's unique functions into separate areas of the Salesforce organization. All those live under that one organization, which creates a single entry point for all the user types and work roles to My Conservation Life. So, secondly, we have an external database. It's a Postgres database used to store that very large amount of data. Salesforce has some internal limits on how much you can store, so we opted into having this external piece of it. But with that, we are able to leverage PostGIS, which is an add-on to Postgres, to relate our data to geospatial locations. So we can take the data across projects and relate them to each other based on the physical locations of where they are. And then lastly, to make our Salesforce organization and apps talk to each other, we have an intermediate API built upon Node.js that lets our Lightning Web Lightning Web Components communicate to our PostGIS database. And then to tie it all together, we have one Salesforce organization that holds our 3 apps, the Zoo Staff, the Field Participant, and the Community. Each app has a collection of web pages that belong to it, and then on each web page there is a mixture of out-of-the-box Salesforce components that talk to internal data, such as user data, and then our custom Lightning Web Components that talk to our external PostGIS database through that API.
Now I'd like to give you a tour of my conservation life. In doing this, I'm going to show you how each user role that uses my conservation life, starting with a donor to conservation projects, zoo staff, and then field participants, how each of these user roles can use our 3 My Conservation Life applications. So I'd like you to put yourselves in the shoe of a visitor to Seneca Park Zoo, and at the end of their happy visit, they go to the gift shop and they pick up a stuffed animal. The stuffed animal also says that when you buy this animal, you are sponsoring a tree in Madagascar and replanting it. So given this story, I'm going to give you a live demo of what it's like for this user type to use my conservation life. So our My Conservation Life community application is a public website where people can visit to see ecological assets across conservation projects across many organizations. Currently, we have 3 conservation projects demoed here. We have a Madagascar reforesting project, we have a lemur conservation project, and we have an African elephant conservation project. You can learn more about a conservation project at our project page, which will show you the ecological assets, in this case trees, of projects like the Madagascar reforesting project. Now, attached to my stuffed animal, I have an access code. I want to redeem my access code so I can learn more about that tree I'm sponsoring in Madagascar. So, I already have the access code typed, so I'm going to paste it in right here. And when I submit, that access code is redeemed to my Conservation Life community account. So now I'm going to take you behind the scenes and show you how zoo staff and field participants use My Conservation Life to keep track of these ecological assets and conservation data. So we're going to begin by looking at the My Conservation Life zoo staff interface. So I'm going to switch over here. And if we open up the zoo staff application, we are able to see in a table format all the ecological assets across all the projects that my organization is managing. So we could see some examples of lemurs, trees, and elephants that are assets at particular points in the world. With the tools on the left, we're able to filter down these and see particular types of assets and from particular projects. I'm going to show you how we generated that access code that we redeemed as a donor. So if we go to the access codes page, we are able to view a list of access codes we have generated, who has claimed them, and generate new access codes. So I'm going to generate a new access code. And what this does is it selects an ecological asset from our database and creates an access code for that. Now I can print this out and attach it to a stuffed animal. So that concludes our donor story. Now I'm going to show you how a zoo staff can add a new type of asset to our project. So conservation projects can manage various different kinds of ecological assets. for each kind of asset, we create a asset definition to identify what pieces of information we're collecting for each kind of ecological asset. So if I go to the Create Asset Definition page, we are going to create a baobab tree. So type baobab. A baobab is a tree that's special to Madagascar. So it's a tree in Madagascar. And for this baobab tree, we can identify what properties we want to track for it. So we're going to track two properties. We're going to track age, the age of the tree. We can select the type of data that we're going to record for this. So and the age is a number. And for our conservation project, age must be tracked for each ecological asset. So to enforce this, we check the required box. Now I'm going to add one more property to identify the diameter of the tree. And this will also be a number. And this property is not required, but it is private. What that means is the public would not be able to see this property of the assets. So we support hiding certain properties of assets. Sometimes this is necessary to protect where ecological assets are in the world. So once I'm done creating an asset definition for the baobab tree, I can hit save. And now we are able to create baobab trees and add them to our database. The people who do this kind of activity are field participants. So field participants are out there in Madagascar planting trees and recording information. So if we switch to the field participant application, we are now able to create an instance of the baobab tree. So if I click select an asset type, we can pick our baobab tree, and we have to, all assets have a location property. So this tree is going to be in Madagascar. So I'm going to type in coordinates for Madagascar. And this tree is 783 years old and has a diameter of 8 meters. So I'm going to save this. And so now we created a baobab tree. If I go to display assets in either of our applications, the zoo staff or field participant, we are now able to view that baobab tree in the table. So there's our baobab tree. So now we'd like to discuss how we implemented quality assurance for our project. So I'm going to switch back to the presentation.
All right, so being a large project that will be developed and maintained for a long time, a critical requirement for us was to create a solid foundation for future development. So as any project progresses, it is essential that everything is documented, tested, and easy to pick up, as if all of the original members left and were replaced by a brand new team. Aside from all the documentation, we implemented several measures to ensure that we built a quality foundation. So this includes pre-releases for user acceptance testing, 41% unit test coverage for every major component in our technology stack, as well as 89% database integration test coverage to assure a reliable backend to database integration. But that's enough about QA. Let's talk a little bit more about the distribution. So thanks to our technology, choice of technology, primarily Salesforce, we can distribute most of our system in a single package within Salesforce. Unmanaged packages will encapsulate everything we've created to interact with the conservation impact database, and will include all the dependencies as well. Unlike a managed package, the system can be released by unique versions, so that decision was based on this. While Salesforce may always be on the same version in production, their database may not. So in order to have it compatible, we want to use the unmanaged package released version by version, just to maximize that compatibility between all the different organizations that may acquire this tool. These packages will include all of the Salesforce Lightning Web Components that we've created, and it will be at the discretion of the organization installing this package to choose the layout and general organization of the contents within the package. So all of the components within the package can be drag and dropped to any page that they choose, which is another benefit of the Salesforce platform for anyone who's not familiar.
Moving forward, so we are the first senior project team to work on My Conservation Life, but we will not be the last. So something that was important to us while we were working on this was to ensure that when we pass this off, it will be a smooth and easy transition for the next team. With that, we have made sure to have lots of documentation and artifacts that we have stored. We have organized those and tried to make it easily accessible for the next team when they need it. Currently, we are working on 2 more documents before we wrap things up to help them transition. One of those are developer documents, which detail how we implemented the various pieces of our project and how they can implement them, and just going through those steps because they're going to be doing a lot of the same work. Additionally, the technical report, which is also something that we'll all be doing, is going to go over a lot of the why we made certain decisions, and this will help explain not just what we have, but also what we were thinking about when we made the different decisions in our project. So actually just a month from now, the next team will be coming in to start this project, and with that, they'll be looking through our documentation, and of course, our documentation won't be perfect, so we have also provided them with our contact information. That way they can ask us any questions for things that are maybe still left unanswered. Another thing we've done to help make this transition smooth is we have gone through the different requirements that our sponsor would still like to get to, and we have detailed some next steps that they can get to, things that we think would be good for them to get introduced into the project so that they're not tackling a whole lot of stuff at once, but still learning about the project while doing something that they can handle. And so we think that that'll make it easier for them to transition into their work. But that's the next team. What about our team? So some things were good and some things were bad. So I'm going to start with what was good, and I think something that went really well for us was communication. As a team, we communicated well with one another. We got along, as well as we were very clear about what we were doing, what we were going to do, and what we had accomplished. And so this helped us just make sure we always knew what was going on within the project. Additionally, we communicated well with our sponsor, and I think particularly we made sure that we were always doing what the sponsor wanted, and the sponsor definitely made sure that we always knew what was going on for this project. Here, I think another thing that went well was setting up the groundwork. As mentioned, this was a significant portion of our project, was setting up the groundwork for the next teams to be able to continue this. And so we spent a lot of time just making sure we made the right decisions, documented the flow so that the next team can pick up right where we left off. Another thing that went well for us was our process. During the first semester, we had 1-week sprints, and then later we transitioned to 2-week sprints. The reason to have the 1-week sprints was to make sure that we were clearly defining what we would get done each week and then actually accomplishing those things each week. And so this set us just on a good track to have that weekly progress, which was really important. And then later we slowed that down so that we could more clearly define what we were trying to accomplish for each sprint. So now on the bad side, I have up there the picture of the crossed out graph. I think we didn't handle metrics as well as we could have. We did a lot of time tracking for the different estimations and actual we're all familiar with. Also how long all the different tasks took, the backlog items, tracking just how long everything was taking. And this was definitely important. It helped us know what was going on. But we didn't make as much use of those numbers. We didn't plan many reactions for if they were too high or too low. And so making more use of those metrics is definitely something we could have done better. Down there, I think we had a somewhat slow start. And part of this is just the trade-off of getting that groundwork together versus just jumping right into things. But during the first semester, things definitely felt a bit slower. And eventually we had picked up that pace. Overall, though, we're all very happy with how this project has gone and where we've ended up, and we're very excited to see what happens with this in the future. So thank you for listening. Do you have any questions?
Yeah, why such long codes to type in?
So we went.
As a person who's typing a lot of
Right.
code on product,
That was kind of a shortcut we took to make a demoable product, and that's really just using the Salesforce ID. So that's what they generate, and to save time, we just stuck that right in to register them all. It was a last-minute feature, but it was good. It works.
they gotta save a lot of trees.
There's space for more trees than there are atoms in the universe. Compared to the number of code.
How did you decide to go with Salesforce over maybe some other tool? And can you explain, was there any other way that you could have solved this problem without using Salesforce?
So I know for sure that the Seneca Park Zoo is currently, working with Salesforce in certain ways. So being able to integrate with that and use that more for them was definitely a pro for us. There's other tools that could do that, but I think that was something that we jumped on to start with, and we kind of just liked it to start. So we just continued with that.
Another thing with that, though, is just recently, a couple months ago, they released their Lightning Web Component to be open source. When we first started, and I had the thought that you could just make this all in a separate web app or something. But they released that open source, which means you could potentially create, just like any other web component framework, like React or Vue or whatever. You could just put these components that we created under a different website. But I do think they want that to be integrated into their current processes. So Salesforce is where we were.
You talked about how there was a data storage limit in Salesforce. Were there any other challenges that came up with using Salesforce for these measures?
I guess the initial learning of it, it's very configurable, so you just have to have that learning process in the beginning. We did have a resource to utilize who was working on this kind of before, just purely in Salesforce. But yeah, it was difficult to get started with it and to learn where everything was, where it was, so we could utilize it the best we could.
Yeah, and to add to that, Salesforce is way bigger than I ever imagined. So with their Lightning Web Components, they have a whole Trailhead community, all based off of that, and they have tutorials, guides, and a whole community behind that. So that was a very useful tool for us to get into it and figure out what the Lightning components were.
If you do not, how did you handle the authentication part of the component? Being a field operative versus someone else, how could you determine who somebody was?
I can answer that question. So all authentication is done through the Salesforce organization. So apps can be assigned to Salesforce groups. So for each of our roles, Zoo staff, field participants, we're able to assign them the particular apps that are relevant to them. And Salesforce manages registration on our community for the donors. And at Seneca Park Zoo, they already have Salesforce accounts for their employees. It takes care of authentication for us.
Okay, let's thank the team.